Hi, so today we are going to talk about triangle inequality, which you probably don't care about it anymore because, well, quiz 2 is not on this. But the second and third point set operation this and proves that identities are really important. They are always tested, either usually on quiz 2, sometimes on test, and sometimes on the final exam as well. So those two are more important than triangle inequality, I would say, because the first part, triangle inequality, was rarely tested in this course. So they tested like every few years, like every 5 years or something. Probably less than that, probably every 3 years or something. So triangle inequality not as important, but I still want to talk about this. So let's look at the inequality itself. It says for any two real numbers, x and y, we have the absolute value of x plus y is less or equal to the absolute value of x plus the absolute value of y. So again, as I mentioned in AGM, okay, I mentioned in AGM that your x and y, they are not necessarily just x and y, it could be anything. So my way of thinking about it is they're just anything. Okay, so I usually write it as something like, oh, absolute value of circle plus square is less than or equal to the absolute value of circle plus the absolute value of square. Okay, so remember, they can be anything. They don't necessarily just need to be x and y. For example, this thing can be x plus y, and this thing could be minus y. Then the whole thing will just be x. See? So that means the whole thing will just be x. So there are many ways to modify it. Just remember, they could be anything. They are not necessarily just x and y. Another observation that I want you to look at is on this side of the inequality. Okay, on the smaller side of the inequality, you only have one term. What do I mean one term? So everything is inside of the absolute value symbol, so we consider it as one term. However, on the bigger side of your inequality, you have two terms. And it's sum of two terms. So remember, this side will be sum of two terms. Okay, so the reason I make this observation is because a lot of time when they give you triangle inequality questions, for example, this one, not just this one, a lot of time, if you realize that on this side of the inequality, you only have one term. On this side of the inequality, you have sum of two terms. A lot of time, it's going to make your life much easier by rearrange whatever you need to prove. For example, let's look at example 1. Okay, as I mentioned, I want this side to have only one term. Okay, and I want this side to be sum of two terms. So how would you rearrange this? This is just like rough work or observation. How would you rearrange this so that it looks like my triangle inequality? Divide by -1, that's gonna make this side still difference of two terms though. So move it around, rearrange it, and see what you have. Like for example, you can move this to this side or something like that. So how would you rearrange it so it looks like my triangle inequality? X minus y plus y, what do you mean? Okay, you're overcomplicating it. So what I would do, let me show you what I would do. It's fairly simple. So this is minus. If I move this to the other side, it becomes a plus. So it becomes x plus x minus y. It's greater than or equal to, if I move this to the other side, it's gonna be plus as well. is greater than or equal to y. Do you see my observation? So now my smaller side has only one term. My bigger side is a sum of two terms. So it's fairly simple. It's not that complicated. Okay, so now I'm gonna say that this looks like triangle equality. So I'm gonna move this to the other side so that it looks more like triangle equality. So this is just y, right? Yeah. Okay, so this is what I need to prove. And this is my triangle inequality. Okay, I'm gonna leave it here. Now, can someone tell me what is my square and what is my circle? So you're saying my square is x minus y, and my circle is y. But this is but x minus y plus y is x, so this is y. You're really close, really, really close. Y minus x and x, that's correct. Why? Because, well, this is the same as this. Do you see? So now let's let circle be x, okay? Square be y minus x. Done by triangle inequality. I would have absolute value of x, I mean, absolute value of circle plus square. So circle plus square, okay, is less than or equal to absolute value of circle, which is my x, plus the absolute value of square, which is y minus x. So this is what? This is x minus x. So that's just gonna be y. Is less than or equal to x plus. This is the same as x minus y. Now I'm gonna move it back. Okay, so I'm gonna move it back. So I'm gonna move this to the other side, and is it this to the other side? Yeah, this to the other side and this back to this side. So that's gonna be minus is less than or equal to absolute value of x minus absolute value of y. That's it. That's the end of my proof. Are we allowed to use circle and squares on test? Well, it's up to you. They're just dummy variables. If you want, you can even use, let's say, what? Okay, it's better that you use something like A, B, or something like that, but doesn't really matter. Whatever works for you, that works. You can just say my circle and squares represent your real numbers or something like that. Doesn't really matter. Wait, so would this level of proof be good enough on the quiz? Yeah, it's good enough. So it would be better that if you write them as A and B. However, if circle and square helps you to understand how to approach this, then go ahead and use them. Yeah, you're probably writing too much. Okay, any question? So something you should, yeah, this is 100%. Well, this is not part of your proof though. I'll change the color so that you know what's part of my proof. Okay, that's it. Are we good? So no words. Oh, words, yes. You should add some words in your proof to be a good proof. However, this is not a well-written proof, but it doesn't mean it's wrong. So for your quizzes and tests, you are under time strain, and I don't think it's a good idea to put too many words on it, because that's wasting your own time. So as long as your proof is correct, okay, so 3 things you need to do. 1, your proof is correct. Okay, second, you didn't use anything out. You only used what's covered in class. What's covered in class. And 3, you justified your steps. Okay, if your proof satisfies all 3 conditions, then you get 100%. Does that make sense to you? Daria joined your lecture and scared everyone. Well, Daria is quite harsh on marking, but you don't have to worry because I'm making a marking scheme, so we're not gonna be super harsh. At least I'm not gonna be super harsh, so they are not gonna be super harsh. If they're too harsh, I'll stop them. Don't worry. You definitely should. Do you get a random marker? So it's 1 marker that marks for everyone. So for example, your quiz 1, I marked everyone's question 2, and another marker marked everyone's question 1 and question 3. So this is like fair, because if like different TAs mark the same question for different students, they have different standards. It's gonna be hard it's gonna be unfair for some students because everyone have different standard and they mark differently. That is why I'm trying to only pick 1 TA to mark everyone's question. So it's fair. So if 1 TA is harsh, at least you're harsh for everyone. So it's consistent and really fair. All right, do we have any question? Why? Because this equals to negative x minus y. Okay, and when you take square root, oh no, when you take absolute value symbol, the negative 1 disappear because, well, we don't care about it anymore. You're the same thing. So this equals to absolute value of x. Cool, move on. Because this is really not that important. So let's move on. Let's talk about something more interesting and important. Set operations. So I have a whole, all the definitions put here. But for the first 1, 2, and 3, 1, 2, 3, I'm not gonna look at this definition. So go down a bit. Oh, you know what? I forgot to give you a light version, did I? So for those of you who need to print it out, it's bad for you. Sorry, I'll do it now. I was gonna say you can write it, but I forgot to give you a copy to write on top. So that's bad. Give me a second and compile it and then send it to you really fast. Okay. Come on. Print on black paper. That's bad. There we go. I got it. I'm just gonna name it. Oops, I named the wrong file. Tutorial 2 and light. There we go. Okay, so if you want to print it out, you can print it out. Anyway, first 3, I'm gonna do this because this is what people always make mistakes on test or quizzes. So I hope after I cover this, you don't make mistakes on this anymore. So I'm gonna talk about union first because, well, I don't know why. There is no reason. I just want to talk about union first. So union of two sets. I'm gonna draw a diagram. And where are you going? This is my A. This is my B. This is my A. This is my B. The rectangle is my universal set. I'm gonna duplicate it and do it again. How many copies do I need? I need 6 copies of this. Okay, continue. And lastly here. All right, so this is my union. What is, okay, and this is in my union. So it is an element of my union. And the next graph is it's not an element of my union. Okay, so if X, let's say if X is an element of A union B, then where could X be? Okay, so that's a question for you. Think, where could my X be? Okay, hold on. Need to use this. So X is in A union B. Hello? What's going on? Oh, I see what's going on. My bad. Oh, okay, bad. There we go. So if it's in A union B, then X could be anywhere here. Who's texting me? Could be anywhere here. Okay, so this means it could be in A, it could be here, it could be here, could be here. So it is in, this is equivalent to X is in A or X is in B. This is what everyone knows. What people do not know is what if it's not in A union B? That means it's not in what we highlighted there. So it's gonna be outside area, right? Ah, come on. Come on, why are you doing this to me? So it's not in what I highlighted in the first picture. So it's somewhere here, could be anywhere here. So this means it's not in a union. It's somewhere here. So X is not in a union B. What does this mean? It means you cannot be in A and you cannot be in B. Do you see? You cannot be in A and you cannot be in B. If you be in any of them, then you are in A union B. So this is equivalent to X is not in A and X is not in B. Keyword is and. So the keyword of this is and. Here is or. Similarly for what? For intersection. If X is in the intersection, then it's somewhere here. Okay, so that's X is in A intercept B, which is equivalent to X is in A and it's in B. Okay, it has to be in both. Again, keyword is and. Right? If it's not in A intercept B, then it could be anywhere other than this part. You see? So what is not in? Oh. So what is not in there? Ooh, okay, that's big. That's big. That is big. Okay, that's okay. I'll just erase the extra part. Ooh, ooh, okay. And let's erase the extra part, which is here. So we don't want it to be inside. And we don't want it to be outside of the rectangle either. So this is x is not in A intercept B. What does this mean? This means x is not in A. Is it or and here? Or, right? It's not or, it's not in B. Why? Because well, you can be in B, but still not in A intercept B. Okay, see, you can be in B, but still not in the intersection. You can also be in A, just as long as you are not in both, then you are not in the intersection. That is why it's or here. Okay. And the last one is difference. I'm so slow. We need to be faster. Difference. So let's say x is in A minus B. Oh, okay, that's big. We change it to smaller. So A minus B will be this part. Okay, so let's say x is in A minus B. That means x is in A and x is not in B. Okay, not in B, but in A. What happens if we let it not be in A? Oh, oops, not be in A minus B. So that's gonna be everywhere except the highlight part. So it's gonna be something like this. Oh, come on. Sorry, it really bothers me when it's different color. I have to fix it. Why can't I make it perfect? You know? Okay, not this part. So not anywhere in this part. Oops, I missed one part. It could be in here as well. Oh no. Whatever. I guess I don't really care. As long as you understand, it's okay. I said I care, but I'll fix it after the tutorial. I do care. Just probably not gonna waste time now. Okay, I don't know why I'm still erasing. I do care. Oh, okay. Fast, 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 fast. You know what? I'll just fix it after tutorial. It just really bothers me. Okay, so this is x is not in A minus B. What does this imply to? X is in B, not in A. Or it could be in A, see? Could be in A. The keyword I'm missing, is it or and? There we go. It's not in, it's X is not in A or X is in B. Okay, so either you are not in A, so you remove this part, so everywhere else, or it's in B, so as long as you're in B, so that added this intersection part. Do you see? Okay, so it's not in A or it's in B. Everything here, you can use them directly. Okay, everything here, you can use them directly because it's by definition. And make sure you don't make the mistake about the keywords, because that's where people make mistakes. Complement, simple, okay, just remove whatever you don't want. So A complement means we don't want it to be in A. B complement means we don't want it to be in B, and so on. Cartesian product is an interesting one because your professor really liked to test you on this. So let's put a star next to it. Cartesian product is a set of ordered pairs. Ordered pairs. Ordered means order is important. Order is important, which means x, y, and yx are not the same, right? Pairs means you have two numbers. Okay, pairs, you should know what's pairs. So what's the definition? So A, Cartesian product B means you have ordered pair xy where x is from A, y is from B. Question. Do we have any question? Are we good? Give me a thumbs up if you're good, or type something in the chat if you're good. Cool. Next. De Morgan's law for sets. In your textbook, you have the first one. In your lecture, you have the second one, so you can use both directly. However, for those of you who took 102 last semester, you know that we have another De Morgan's law, which is for logic. Since we're not in the next chapter yet, you cannot use De Morgan's law for logic. Does that make sense to whoever know what's De Morgan's law for logic? Those of you who know what's De Morgan's law for logic, you are banned from it, okay? You cannot use them yet. When we reach the next chapter, you can use them, but at the moment, no. You can use those too, no problem. De Morgan's law for logic, no, okay? Do not use it, you'll lose mark. I guarantee you'll lose mark. Okay, move on. Those two are simple, really easy. That's good. If you don't know, that's good. I know you know, but if you pretend that you don't know, that's good. Okay, next. This is an example from past final exam. Before I talk about this, let's talk about how to prove two sets are equal. Again, if you're from last semester, you really should know this already, but we'll still talk about it because not everyone took the class last semester. So if we want to prove A equals to B, honestly, I feel like if I took this course last semester, I wouldn't even join tutorial. I don't know why you guys are here. I'm not trying to kick you out, by the way. In case you took my message wrong, you need to prove two things. The first thing is you need to prove A is a subset of B. That's your first step. Second step is you need to prove B is a subset of A. Okay, so for those of you who are taking this course for the first time, how do I prove the first one? What do I do? How do I prove A is a subset of B? Getting all elements in A and see if they're also in B. Exactly. So you want to prove for every element you have in A, they're also in B. But we're not going to check every single element. Instead, we'll just pick a random element. We'll pick an arbitrary element from A. So what we're going to do is we're going to suppose X, this is an element of A, and then you need to use your set operation definition. Okay, eventually, if you can get X is also in B, then you prove that A is a subset of B. Similarly, to prove B is a subset of A, you need to pick an arbitrary element from B do some work magic in between, and then if you can get X is an element of A, then B is a subset of A, and they're equal. And you're done. That's how you prove two sets are equal. This will be tested multiple times, so make sure you know how to do this. Hello? Hello? Why are you not doing your work? I need a new iPad. Do your work. Come on. This is it because my hand is shaking? There we go. Okay. Oh, my pen, okay. All right, so remember this is what we need to do. Now, do we have time to do everything? Set. We're not gonna get to 3 and 4. Now, because I want to let you try it. For example, if one set is a formula and the other set is a series of coordinates, how would you prove they're equal? What? I don't understand. One set is formula. Oh, you're asking about your first question from assignment, aren't you? I knew it. I knew it. Well, as well, you need to check their subset of each other, which I actually did in one of my tutorial, but I took it down so that people don't copy from me. So this question will be answered after you hand in your assignment. I took down this. I actually look, let me show you. I took this tutorial down so that people don't copy from me, because I actually did a really similar question in my own stuff. Where can I find it? But I took it down, so you cannot see it until you hand in your assignment. Yeah, you can't see it anymore because I took it down. You'll see it after. Yeah, you'll see it after. Hopefully you cannot see it here either. So let me check. It's not here. Maybe here. Oh, it should be here. Tutorial 2, yeah, this one. So I did a really similar question in tutorial 2, but I took it down so that people cannot copy my solution. Because people always you can have a link, but I set it to private so you cannot watch it anyway. It's not. I don't believe you. Example 2. Let's do this one. I want to give you some time to think about it before I take it up, but that means we will not have time for the last 2 questions, but that's okay. Doesn't matter. Not important. I'll give you 3 minutes to think about it, and then 4 minutes to think about it, and I'll take it up. 4 minutes. 4. Where is my timer? Oh, here. I'm blind. 4 minutes to think about this question. So think about it. How would you prove? Where do we find problem set B? It's on quad mark. Is it lagging? Is it lagging for anyone else? Well, if the time is not changing, then can you go back to the question? Sure. It's on quote mark. Do you guys not check your email at all? You should receive an email about your problem set. You definitely should check your email every day, because all important things will be sent to your email. So you should definitely check your email regularly. I check it every day, sometimes more than once a day. Okay, not sometimes, every day I check it more than once. I always check in Piazza. Oh, do you not know you can turn it off, the Piazza thing? You can turn off the email notification so you don't get it ever again. Yeah, of course you can. Yeah, go to settings and ask them to stop emailing you, then you don't have those Piazza thing. I know it's really annoying because I'm TAing 5 courses and it's really annoying for me as well. Just turn it off, guys, turn it off. Turn it off and check your email. Make sure you get whatever you need to get. Because if there is anything important that we wanna tell you, we're gonna email you. Because I don't have your phone number. I'm not gonna call you, you know? Don't give me your phone number. I'm not gonna call you. Yeah. So my point is email is the only way we can contact you. So you should check it regularly. I'm bored. Is it time? Oops. Oops. Oh. Oh. What did I do? Is it time? I don't know your final exam. It's not up yet. Marina usually make it. Oh, no, those are past final exams. I have all the past final exams. Your quiz 2 is not even made yet. Do you know, like, if your quiz is on Thursday, Marina usually make it on Wednesday night. So if you ask her anything on Monday, she's not even. She. What? What do you want? She hasn't even. Okay, let's do this. She is a queen of procrastinating. Okay, I'll pet you. Enough. Sorry, my dog want me to pet him. Okay, so how do I do this? What's my first step, guys? Double inclusion. So let's do the first direction. So let's do C is a subset of A union B. Now let's let X be an element of C. What do I do next? Sit. Bam. Hello, you're dead. Bam. Yeah, I know I need to prove X is in A and B. And B? And B? Union is and? Or, okay, how do I prove it though? Do you guys want to see my dog? I'll show you my dog. Okay, Barney, come. 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 He's not listening to me. Come. Show them your face. Get up. Good boy. Okay, turn. He doesn't want to see you. Sorry. Turn your head. Okay, up. Show your face. Show your face. Hello. You smell bad. You need to. Come on. Show your face. Do you see his face? Puppy, he's not a puppy anymore. He's huge. He's 40 kilograms. Okay, that's it. Back to 102. Let's do it fast. What do we have is we have, well, A is a subset of C, B is a subset of C, C minus A is a subset of B. Now we're gonna say, but how do I use this to show this? Simple. Why is it simple? If it's an element of C, then it might be in A or it might be in B. We don't know if it is in A or B. We don't know, so we can discuss cases. So my first case is, suppose it is in A. If X is also in A, well, A is a subset of A union B, which means, well, X is in A union B. Okay, so this is what happens if it is in A. If it is not in A, hold on. I want to change the color a bit so it's more clear for you. If it's not in A, because your X can either be in A or not in A. If it's not in A, then X is in C minus A. Why? Because X is in C and X is not in A, so it's in C minus A. C minus A is a subset of B, and B is a subset of A union B. So X is also an element of A union B. And we're down. You get X is an element of A union B in either case. Does that make sense? Any question? I feel like you guys are more active when you see my dog. Do you want my dog to teach you 102? You should petition to change. Yeah, because we actually like dogs. What do you mean? So you mean you like Brownie but you don't like me? I will set up a petition to replace Leon with Brownie. Is that what you want? Okay, next, I'm gonna show A union B is a subset of C. This is even easier because, well, let X be an element of A union B. Then X is in A or X is in B. How do we conclude from here to X is an element of C? Anyone? Anyone? A and B are in C, not in C, they are a subset of C. Okay, so since, because E means element, since A and B are subsets of C, by definition of subsets, X is also in C. And you're done. So therefore, they're equal. And we're done. Question? This is sad because I don't get to do the last two questions. Oh, no, we'll do them next week. Oh, no. Next week I should do something else. Someone has your camera on. Let me see your face. Ah, sad, okay. Too fast. All right, do we have any question? 102 babies? Or 102, are you 102 babies? Or a math babies? I'm a math baby. Didn't I just say we'll do them next week? Or not? I don't know. Let me see. I don't know, people. Let me see what's my plan for next week and I'll let you know. We should do image next week, right? And fields. Well, what's on your problem set C? Or what's on your quiz? We should know those. Let me see. Problem set C has what? 2.5.21b. Oh, this is an image question. This is also an image question. What's 2.5.33? Huh, let me check. Let me quickly check and I'll make my plan based on your quiz material and I'll make my plan based on what we're gonna do next week. Let me see. 2.5.33. 25 ABCD. Oh, this is simple. 33 is image as well. Okay, simple. Okay, so plan is we'll do image next week and we'll do the rest of the two questions next week. Cool. No fails on quiz 2, it seems like. Are we happy now? People, are you happy now? Are you satisfied? Are you happy? Yeah? Okay, then you can leave now. Can you repeat that? You're like, I said, are you happy now? I said I will do the rest of the two questions next week along with image because your field looks like field will not be on your quiz too. So we'll do those. We will do image next week. And if you're happy, you can leave now because that is the end of the tutorial. It says what? It says 2.1, 2.2, and 2.3, really? But the questions don't have field questions though. The whole problem set C doesn't have any field questions. I don't know. Well, she doesn't post anything yet. But problem set C does not have any field questions. What if you are not happy? Can you still leave? No. If you're not happy, you stay here. There is quiz 2 information already. Where is quiz 2 information? Oh, I see. My bad. Huh. Interesting. I'll ask her. Okay. I'll email her later. And I'll let you know next week. That is interesting. But her problem set C has no field questions. Well, okay, then we might have filled next week. If that's the case, I will hold an extra tutorial. Sometime this week or next week, I don't know. Sometime before your quiz, we'll have an extra tutorial. How's that? A fields is on your quiz. If not, then no. Are you happy now? No? Okay, here. Do we check Quarkus? No, I'll email you. As I said, quiz 2 information says it's on the quiz, but problem set doesn't have any field questions, so I will confirm with Marina. And if field is on the quiz, we'll have an extra tutorial. When and where I will email you. If it's not gonna be on the quiz, then we will not have an extra tutorial. So I'll see you guys next week. Problem set B is on quote mark. That is why it's not on Quarkus. You should check your email regularly so you know where it is, where to find it. And let's clear those. No spoiler. If you're happy, you may leave. Bye. If you're happy and you know it, please leave. You know?